I know, you deserved a short one after that last one. Okay, after the first one was 15 minutes, last one was 2.5. We're good. This is 12.5 part 3. Okay, interval, graph, and set notation. Again, this may be something that you know or are familiar with, but I need to be sure that you're really good at it. So let's start with putting everything in graph notation, and that's going to be your go-to because it's not going to get simpler, it's going to get more complicated. So if we're looking at the numbers between and including 2 and 7, this is graph notation. You might know set notation or set builder notation. And I was looking at some of the stuff from UNM, and they use set builder. So let's talk about set builder notation. And we're going to be completely thorough with it because this is what I've also seen them do. So we're going to say, we're going to use a brace for set notation, little squiggly, and we'll say X is a member of the set of real numbers. So we're talking about everything on the number line. I'm going to use a double barred R, such that, and that's either with 2 dots or a vertical line. I'll use both for you, such that all these values for X are sandwiched between 2 and 7. So I'm going to put an X in the middle, and I'm always going to think about using less than signs, and I need to be able to squish in the 2 there. So I've sandwiched X in between 2 and a 7, and I've got it equal to. So X is, you can look at it the bigger side of inequality. 2 is less than or equal to X, which is less than or equal to 7. Okay, or I could say X is greater than 2, and at the same time, it's got to be less than 7. So that's set builder notation. Down here, set builder notation, if I'm talking about the numbers greater than but not equal to 8, I'm going to say X is a member of the set of real numbers. I'm talking about everything on the number line, such that, here's the other option for writing such that, it's just a long vertical line, such that 8 is less than X. And I end with my brace. So these are set builder or just set notation. The notation you're going to move towards is interval notation, and that's what we're going to look at here. So in this last column, I'm going to put interval notation. Interval notation. Work with me on my handwriting. It's not good. You're going to like it. An interval refers to, like a line segment and all the points on that line segment. And you can have an open interval, which does not include the endpoints, or a closed interval, which does. So this is a closed interval. So I'm going to express it with brackets 2 to 7, and I always have to have the lowest number first. So then the question is, how do you represent an open interval when you don't want to include, say, the 8? There's where it begins. And then also, so with a parentheses, and then also, how do I express this if it goes on and on forever? Well, it goes on and on until infinity. So I love writing infinity right next to the 8 for obvious reasons, and I can't quite grasp infinity. I'm going to use a parentheses, but if you use a bracket, no one's going to scream at you. Now notice you don't have inequality signs in interval notation. Notice you do not have infinite signs in set builder notation. That's a really important difference. Here's an example of a closed interval between 5, and I wrote them larger, 5 and 15. 15, I don't know what it was. It was too small for me to read it. 15, and this looks like 13 down here. So here's the closed interval and the open interval. Now some of you may have learned, instead of filling in the holes, you may have learned that you can put a bracket here. Some of you may have learned that you can use a parentheses here, and those mean exactly the same thing. So let's sail by the chart. We'll go back to the chart in a second. But right now, see if you can express each of the following sets of numbers in the 2 missing notations. Say, for the first, it looks like you've got set builder notation. Put it in graph notation first. Always put things in graph notation first, and then try interval notation. Oh, wow, there's 5. Go practice this. Here's the first 4, because the 5th one gets a little funky, because we're saying X is Z, Zal, integers. Which values are we looking at there? Now I want you to notice a couple things. Notice the use of union. We use union there when we include two different sets, and a use of union there. So that's something that's the same. You might also say, hey, if I have an open interval, that looks like it might be a coordinate. It's like, yeah, you gotta look at context. So see if you can try this. It's a little bit different. These are just integers, and you have to think about what are integers. There you go. Yeah, check out how awkward this is to use interval notation. Interval notation was designed for intervals, for things like this. Set notation is still important. It looks a little bit more awkward when you're talking about intervals, but it's really critical because it's a really nice way of depicting sets of numbers that are integers, for example, or whole numbers, or whatever subset of the set of real numbers you want to. So they're both, all three of these actually are really, really important ways of depicting sets of numbers. Now, just for extra practice, see if you can fill in this chart. Pause the video. I think you've got enough information to go finish it. Pause the video, finish it up, and then check your work. Let's look at the first one together for a second, because sometimes you look at this and you say, oh my gosh, that's so many numbers. You want to think in terms of reading this left to right. Notice they're in order, smallest to largest, and you really want to organize it that way. Notice on the number line, it's smallest to largest. Sometimes when there are negative numbers in there, it kind of feels like it's flipped for you, but always smallest to largest. And you'll note that even in set notation, the smallest numbers to the largest numbers. And you're going to sandwich the x in for wherever you have specific values for x. So in order, -2 values for x, 13, 18 values for x, 21. So notice how that x is sandwiched in between. Some of you might need a little bit more practice with this, but it is a really important skill, because you might have the right answer, but if you can't say what the answer is in symbols that people understand, then it's just not right. So I hope this helps. Let's look at the next. And the next has a hint. Simplify this. The first thing you might notice is this close. This is an intersect. This means you want to take only the points that those two sets have in common. When you have a union, when it opens up, how can I get both my hands in it? Okay, when it opens up, it's inclusive, include everybody, it's awesome, everybody's welcome to the party. When it's down, it's you're being exclusive, so you only want the values that are in common between both. So when you graph this, you can see there's a little overlapping region where the sets are going to be included here. So you want to only include, well, you don't want to include 2, between 2 and 18. It looks like you can include 18, but just that little tiny portion. So I'm going to combine this in a graph, and I don't really have space. So let's include it up there, up above. And I'll say if I were to include this, I want to open interval at 2, all the way up to 18, and I do get to include 18 because the point 18 is included in both sets. So I can go back and simplify this and say this is equal to 2, 18 bracket in interval notation. Let me show you the whole thing. And then I can read this in set notation. X is a member of the set of real numbers such that 2 is less than x is less than or equal to 18, less than or equal to, because that's filled in. Now continue along your way and see what else you can. Here we go. Check that out. I wasn't sure I read these numbers right, so I might be a little off. I can't tell if that's a 82 or an 81. So work with me on that one. I tried to at least be consistent between the sets, and I didn't bother putting this in interval notation because it'd be a bunch of those brackets put together. So anyway, I hope this helps. Some keys. For simplicity, read left to right, and then you can move smallest to largest for all the numbers. Left to right, smallest to largest, and then use less than signs in your set builder notation. And then you can't miss.